Hey guys, welcome to my video on partitions of a segment. Okay, so before I begin this lesson, I want to make it clear what this partition means. Okay, so let's start out with a ruler. So let's say we wanted to partition 12 inches of this ruler on a 1-to-1 ratio. So 1-to-1 ratio means it's equal on the left side and it's also equal on the right side. So to do that, if it's 12 inches, then we would partition it right here, which is at about the 6-inch mark. So then this is 1 unit to 1 unit is the same length. So like this box right here, right, and then this box right here would be the same length, 1-to-1 ratio. Okay, so that's what that means. Okay. Um, Now, if it's a 2-to-1 ratio, that means we could partition it that the left side is twice as bigger as the right side, which is 1. All right, so to do that, we want to add up 2 plus 1 to get us the total. All right, so 2 plus 1 is equal to 3. So that means the 12 inches is going to be divided into 3 parts. Okay, so if we divide 12 divided by 3 parts, you'll get 4 inches in each part. So every 4 inches, so 1, 2, 3, 4, that's a partition in itself. Then 1, 2, 3, 4, that's a partition in itself. All right, so right now you have created 3 equal parts. Each part is 4 inches. Okay. Now, in order for you to show the partition of 2 units to 1, you can either say, well, this shaded region, I'm going to highlight it for you. So this shaded region is 2 inches, two units. All right, and then this area right here shaded is to 1 unit. All right, so that's one way. All right, so another way you can partition it is to show that this area is 1 unit and then this is 2 units. Okay. Okay, so let's move on with an even a little bit harder example. So again, same idea. If we wanted to show a partition of this ruler 12 inches in a 6:3:2:1 ratio, same idea. We're going to add up 6 plus 3, which is 9, plus 2 plus 1, so 6 plus 3. All right, so 6 plus 3 plus 2 plus 1. That's going to be 9 plus 2 is 11 plus 1 is 12. All right, so we have 12 equal parts. All right, so if you divide 12 divided by 12 equal parts, you'll get 1 inch in each, right? So this is 1, 2, 3, 4. You get the point, okay? So now what we want to show is 6 of those 1 inches, then 3 of those 1 inches, 2 of those 1 inches, and 1 of those 1 inches is going to represent a ratio of 6:3:1. So to show you better, so 6 of these 1 inches, so from here to here is 6 units, and then from here to here is 3 units, right? And from here to here is 2 units, and now it's getting smaller and smaller. From 11 inches to 12 inches is 1 unit. So this is a proportion or a ratio of 6 units, 3 units, 2 units, and 1 unit. All right, so that's what we want to keep in mind. All right, so we want to get the total divided by however long it is, and then we want to partition it using that length, and then go back and shade in what we need to show. Okay. All right, so let's take a look at it in terms of analytical geometry, which is to put things in perspective of the coordinate plane. So in this case, we have A labeled at 1, 0, and then B labeled at 13, 0. So we want to be able to find a point or points on the plane that would partition AB into 3 congruent segments. So it doesn't give me any type of ratio, it's just asking me to separate this into 3 equal segments. All right, so first, in order for us to find out the length of each segment, I first need to find the total length, right? So just like what we did here with the ruler, we knew the total length was 12 inches. So what is the length between A all the way to B? You can count that, right? So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which makes sense because you can also subtract your x's. So because it's a horizontal line, the distance between A to B is 13 minus 1, which is 12. All right, so we know this is 12 units. So the total here is 12 units. And we want to divide the total, right, by what they're asking me to do, which is to divide it by 3. So 12 divided by 3 is 4 units each. So I'm going to count up every fourth unit, it becomes a third, right? So 1, 2, 3, 4. So at this point right here, that's 1/3. All right, so now 1, 2, 3, 4, now that's 2/3. Right now it's 1, 2, 3, 4, that's 3/3, which is 1 whole. So I'm going to highlight it for you. So from here to here, right, from here to here, and from here, oops, sorry, wrong color, and from here to here, that's going to give me 3 equal parts. So the points on this plane that would partition length AB into 3 equal segments are this point, which is 5, 0. All right, that's 1 point. And then this point, which is 9, 0. Okay, that's your final answer. Now let's take a look at a second example. It says, where would you partition the segment joining -3, 0 and 7, 0 to create 2 pieces in the ratio of 3 to 1? So same idea. In order for us to create 2 pieces in a ratio of 3 to 1, we need to count the amount of the distance from A to B. So I can, since it's a horizontal line, I can just count. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, or I can subtract the x's. 7 minus 3 is positive 10. Okay, so I have a total of 10 units. All right. And what we want to know is how many times am I going to split the 10 units by, right? So if they're giving you a ratio, remember to add the two digits together. So 3 plus 1 is equal to 4, so I'm going to divide by 4. So now 10 divided by 4 is 2.5. So every 2.5 of a unit is going to create technically a quarter. Okay, so that's what we want to achieve, is to be able to divide it into 4 equal parts. All right, so now let's begin from here. So this is 1, 2.5 unit. All right, so right there. All right, so this is now a half, right? And then this is 1.5, and then that's 2.5 units. So that's what I want. And then 1, 2.5 unit, and then a half, and then 1.5, and then 2.5. So that makes sense. So let's label this. Let me make that clear where that is. All right. All right. So now I have successfully created 4 equal segments, but I have not successfully created 2 pieces in this ratio. So this ratio means I'm going to take 3 of these parts and then split it to 1 of those parts. So 3 of these parts are going this way, 1, 2, and then 3. And then 1 part is right here. So that is splitting it into a ratio of 3 to 1. So one of those points that's going to split it into 3 to 1 is this point right over here, right? That's the point that's going to split AB into 3 to 1 ratio. So that point is 4.5, 0. All right. Okay, so now there's another way that I can split AB into 3 to 1 ratio, and that's going this way. Okay, oops, sorry, I didn't mean to do that. Let me write that over again. So 4.5, 0 is one of your options. All right, so now the other option is to, let me erase this and then everything that's highlighted. All right, is actually to go the opposite way. So, all right, it was here, here, and then here. Is to go the opposite way. So before we went 3 to 1 ratio from A to B. Now we're going to go 3 to 1 ratio from B to A. Okay? So 3 to 1 ratio could be larger like on this side. So 1, 2, 3, right? And then to 1 ratio, right? So now this point is also possible. Let me change color. So this point is also possible that it would create AB into 3 to 1 ratio. So that is negative 0.5, 0 is a possibility as well. Okay? All right. So that is an introduction to what it means to partition a segment. Okay? So that works wonders when it is a straight line. But what happens when it's a slope line or a slant line. Okay, so here are the directions. It says line segment AB in the coordinate plane has endpoints with the coordinates A, 3, comma, -10, and B, -6, comma, -1. The first question is asking you to graph AB, which I have done for you already. The second question is asking for you to find two possible locations. And remember, they're saying two possible locations because, again, you could start from B and then work your way to A, or you can work from A and then work your way to B. So two possible locations for point C, so that this point divides AB into two parts in the ratio of 1 to 2. All right, so that was easy to do when we were talking about a straight line. So what would happen here now on a slant line? Okay, so the first thing I'm going to do is I'm going to identify the vertical length and the horizontal length to make like a right triangle. Okay, so I'm gonna use red here. Right, so I'm gonna use a red dotted line. Okay, so you could see what I'm doing. So I'm gonna make some sort of a triangle here. Okay. All right, and then I'm going to count the amount of spaces there are going up and then going across. Okay, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So I know there are 9 units going vertical. And now horizontal. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And I know there's 9 units going horizontally. Okay? So once I've clearly labeled out what's my vertical distance and what's my horizontal distance, then the next part to this is to look at the ratio that they're asking me to follow. So the ratio that they're asking me to follow is to divide it into two parts using the ratio of 1 to 2 units. Okay, so 1 to 2 units means that there's a total of, if there's a total of 9 units, they want me to split this into 3 equal units. Okay, so to split 9 divided by 3, that means, well, I'm looking for a third of it is going to be 3 units. Okay, so I'm going to count vertically and horizontally 3 units. So that's and 3 units because both vertical and horizontal are the same distance. So that's 1, 2, 3. I'm going to mark it. 1, 2, 3. I'm going to mark it. Okay. All right. And now I'm going to do it this way too. So 1, 2, 3. I'm going to mark that. And 1, 2, 3. I'm going to mark that. Okay. All right. So now I'm just going to basically draw a line that meets our horizontal distance and our vertical distance. Okay, it's not really perfect. And where they intersect, I'm going to place a dot. Okay. All right, and now I'm going to erase this just to show you that I have successfully partitioned this line. So I'm going to delete this as well. All right, so I have successfully partitioned AB into 3 equal parts. Okay, so I have successfully shown you that this point to this point, I'm going to mark it yellow. All right, that's 1, 2, and then 3. So those are 3 equal parts, right? So that's exactly what I wanted. I wanted 3 equal units. Okay, so now I want to show you where would the point C be so that it's in the ratio of 1 to 2. So 1 to 2 means 1 unit. So I could go from B 1 unit and then 2 units. So 1, 2. So that makes sense. So that means this is a possibility. I'm going to mark it black. So this point is a possibility. Okay, so that's -1, -2, -3. -1, -2, -3, -4. So that's -3, comma, -4 could be our point C. Okay. Now there's a second way to do this. And again, I want to just make sure I'm not erasing over our. Okay, so now we can go from A now. All right, again, 1 to 2 ratio. So this is 1 and then to 2 units right over here. Okay, and then we can clearly see that this point right here, this point, all right, which is negative 1, 2, 3, 4, 5, 6, 7. So point C could be at 0, comma, negative 7. All right, so those are the two possible locations for point C so that we are splitting this line AB into two parts with a ratio of 1 to 2. Okay, so I'm going to show you a second example. The second example is from E to F. I've already graphed it for you. And now we want to find two possible locations for point G so that it divides EF into two parts with the lengths of a ratio of 2 to 3. All right, so I'm going to count up. All right, let me make it red. All right, so I want my horizontal distance. Oops, sorry. Okay, so I want my horizontal distance calculated all the way, and then I want my vertical distance calculated. All right, so it seems like this is quite lengthy, but that's okay. So this is what, 10 units plus 5 units makes 15 units. So this is 15 units going horizontally. Okay, and now this is 11 units plus 7 units makes 18 units. All right, you can count as well, right? I'm just doing it mentally. So again, so that's 9, sorry, that's 9 plus 11, so that's 20 units. My fault. All right, so that's 20 units. Oopsie, sorry. Oh, okay, yeah, that fits now, right? So that's 9, negative 9, all the way to 0. That's 9 units, and then that would be 11. So 11 plus 9 is 20. Okay, so now we want to divide vertically and horizontally in the same ratio of 2 to 3. So we have to do this piece by piece now because the horizontal and vertical distance are not the same. So let's start out with this 20 units right here. So we know our total is 20 units, and we want 2 plus 3, which is 5 equal parts. Okay, so 20 divided by 5 is equal to 4. So every 4 units is going to be it's going to make me 5 equal parts. So that's 1, 2, 3, 4. Mark it. Then 1, 2, 3, 4. Okay, so you want to mark that. 1, 2, 3, 4. Mark that. All right, 1, 2, 3, 4. Mark that. Then 1, 2, 3, 4. So that makes 5 in total. That's 1, 2, 3, 4, 5. And this is going to kind of work itself as well, but I just want to make sure it does. So 15 units now. So if my total is 15 units, then I want 2 plus 3, which is the same, 5 equal parts. So 15 divided by 5 is 3 units. So every third unit is going to be create 5 equal parts. So 1, 2, 3. Okay, you can see that meets. And it almost just always does. All right, so 1, 2, 3, that meets right here. Okay, so 1, 2, 3, that meets with this. All right, so 1, 2, 3, again, that meets with this. Okay, so again, it almost works its way. Let me erase all of this mess. Whoops, I erased that by accident. Okay, let me erase this mess right here. Okay, so now we can show you that this is giving me 5 equal parts. So it's giving me 1, 2, 3, 4, and then 5. Okay, and they're all equal in distance. Okay, so now we want to show the point C where, point G, where G is going to divide it into a ratio of 2 to 3. So 2 to 3, I can go from point E, where I can have 2 of these units, to 3 of these units, 1, 2, 3. Okay, so that makes this point right here a possible point for G this point right here. Possible point for G, that's going to split that into 2 to 3. So what point is that? That's negative 1, 2, 3, 4. So negative 4. So point G could be at negative 4, comma, 1, 2, 3. Okay, so negative 4, positive 3. All right. All right, another point from point for point G, because we can go the other way around. Okay, I'm just trying to make sure I don't erase my points there. Okay, so another way that we can go is we can go the opposite way from point F. So we want to show 2 to 3 parts, so that's 2 units, and then 3 units, 1, 2, 3. So that makes this point right here, a possible point for point G as well. So that's negative 1, comma, negative 1. So negative 1, comma, negative 1. All right, and that is it. That is the lesson on partitioning a segment. Thank you for watching.